when we talk about chemistry of addition reaction on the basis of second point, right, that is about the configuration of product, right, that is about the configuration of product. So if we talk about stereochemistry of addition reaction on the basis of product, then what type stereochemistry, so you can see if trans, if our reactant is a trans, or if our alkene is a trans type, if our alkene is trans type, right, then what types reaction and what types stereochemistry you can see. If this is trans and the type of addition is syn, and the type of addition is syn, then you can see nucleophile and electrophile both come from same site. Suppose that nucleophile attack at back carbon, suppose that nucleophile attack at back carbon and electrophile attack at front carbon, right, electrophile attack at front carbon and nucleophile attack at back carbon, then you can see, right, nucleophile come at this place and electrophile come at this place, right, and this is actually eclipsed form, this is actually eclipsed form, right. Second condition, if electrophile at back carbon and nucleophile at front carbon, nucleophile at front carbon, then you can see here electrophile at back carbon, right, and nucleophile at front carbon, right. So this is also source projection formula, eclipsed source projection formula. This is about eclipsed source projection formula, right. You can see this and this formula, right. Now after that, if you want to convert, eclipsed form into fissure, then it's very easy, right. For interconversion of eclipsed source projection formula into fissure projection formula, we need to convert our compound in eclipsed form, right. So then you can see here, right, then you can see here Nu and E, right, above the plane. It means if E here, then Nu here, right, if E here, then Nu here, right. Actually there should be here Nu and here E, right, exactly here, because Nu, then here should be Nu and then here should be E, right. After that you can see A left hand side, so A left hand side, and B right hand side, so B right hand side, right. A left hand side, so A left hand side, B right hand side, so B right hand side, right. So very simple. Now if you think about this, then E and then Nu, E above upper side and Nu bottom side, right. Then B left hand side, A right hand side, then A right hand side, then B left hand side, right. So now you can see, because here A right hand side, B left hand side, B right hand side, A left, it means this is stereotypes of enantiomers. These two are enantiomers, but they are stereotype, because A and B, they are not same side. A and B, because they are not same side, so it is DL stereotype products. ये जो products बनेंगे, they are DL stereotype. They are DL stereotype, right? So in this way, DL stereotype product will produce. Here E and Nu are not equal. If suppose that E may be OH and Nu may be COH, right? So if two groups are different, then DL stereo product will form. Then DL stereo product will form, right? So you can see here, right? So this is actually here the position should be for Nu, and here position should be for E, right? So then they are stereo. Why stereo? Because A and A, B and B are not same side. If A and B same side, then that is called erythro form. Erythro form, right? So DL stereo form. If trans syn addition, if trans then syn addition, then DL stereo form will form, right? So this is important point. This is about stereochemistry of addition reaction, right? On the basis of configuration of product, on the basis of configuration of product. Now you can see next case. You can we can clear, right, when we discuss one by one case, right? So now you can see if cis, right, it means A same side, B same side, right? So if cis, then Nu same come from back side and E come from front side, right? So Nu attack at back carbon and E attack at front carbon, E attack at front carbon, right? So then you can see they convert into Nu and E, right? Because both from same side, right? Because it is a syn type of addition. So Nu above the plane, E also above the plane, A and B and A and B below the plane, right? Now after that, you can see, right here, if you take second case, right, A and B, if E at back carbon and Nu at front carbon, right, then you can see E and Nu, right? Here E and Nu, so here E and Nu above the plane, right? So now you can see Nu, right, and E same like this, Nu and E, then A this side, B this side, A this side, B this side, right? And here also you can see E, right, a top part and Nu at the bottom part, and then A left hand side, B right hand side, A left hand side, B right hand side, right? So in this way you can see AA same side, BB same side, because AA same side, BB same side, so it is called erythroform. So it is called erythroform, right? So this is called erythroform, right? They are DL erythroform, because you can see, because Nu and E, they are not same. If Nu and E same, then they show, or then they give plane of symmetry, and then the compound will be mesotype compound. But here, because Nu and E are different, so right, so this is not mesoform, right? But AABB same side, so it is called erythro. You people already know erythro. It means if same group same side, then erythro, right? Two enantiomers where same group same side, right, then that is called erythroform. And if same group opposite side, then that is called therioform. So why cis compound, after syn addition give DL erythroform? This is reason behind that, right? And why your trans compound after syn addition give therioform DL, right? Or you can say that enantiomers therioform. This is reason behind that, right? Now after that, next case, our third case, you can see third case which I asked you, and that was part of your homework also, right? So you can see here anti-addition. If anti-addition at trans, right? If we are taking trans, but the addition is anti-type, then what type product will form? You can see this is trans, A and A opposite, B and B opposite, right? Now anti means one group or one attacking group come from above the plane, and second attacking group come from below the plane, right? Now you can see if Nu come from above the plane, then you can see they attack upper part, right? And if E come from below the plane, then they come at this position. They are now like a staggered form. They are not eclipse form. This is not eclipse. It should be clear. This is not eclipse form. This is staggered form, right? You know, there in case of syn addition, the product is eclipse type. But in case of anti-type, the product is staggered type, right? You can see this is staggered form, right? This is Sohor's staggered form, right? This is Sohor's staggered form. Now after that, you can see here, right? Because here Nu come from above the plane, then here E come from above the plane, and Nu from below the plane, right? Then what types of product form? You can see E come above the plane and Nu come below the plane. And this is also a Sohor's projection, staggered Sohor's projection formula, right? You can see here, right? Nu above the plane, E below the plane, E above the plane, Nu below the plane, right? Now, after that, you know, if you want to convert Sohor's projection formula into Fisher projection formula, then you need to first convert staggered form into eclipse form, right? So if you want, अगर आप चाहते हो सोर्स प्रोजेक्शन फॉर्मूले को फिशर प्रोजेक्शन फॉर्मूले में इंटर कन्वर्ट करना, तो सबसे पहले आपको क्या करना पड़ता है? आपको जो स्टेगर्ड फॉर्म होती है उसको एक्लिप्स में कन्वर्ट करना पड़ता है. Then that eclipse form easily convert into Fisher projection form. So this is very important point which I had already discussed when we discussed about stereochemistry, right? तो अब देखिए पहले ये बने, ये दो बने. अब now you can see this staggered form. First we need to convert this staggered form into eclipse form. हमको क्या करना पड़ेगा? इसको रोटेट करना पड़ेगा, right? इसको Nu को ऊपर को रोटेट करना पड़ेगा. If Nu come this side, then A come this side, right? And B come this side, right? And then you can see, NU come at this position because B come right hand side, so you can see B at right hand side, and A come this side, so it is A, like this, right? And here you can see B same or A same. Here also, if it convert, if this convert into eclipse form, because it is a staggered form, क्योंकि ये staggered form है, तो इसको आपको eclipse में convert करना है, तो then you need to rotate it at 180, right? तो ये E आ जाएगा ऊपर, B आ जाएगा right hand side और A आ जाएगा left hand side, right? तो then because B right hand side आ गया, तो B right hand side आ गया, A लेफ्ट हैंड साइड आ गया तो A लेफ्ट हैंड, और ये ऊपर वाला तो एज इट इज रहेगा, राइट? A here and B here, right? And you, right? So then you can see these two are, you can see these two are, because A same side, B same side, A same side, so these are erythro form. This is erythro form. Now you can see if anti-addition at trans compound, if anti-addition at trans compound, then DL erythro form form, right? So this is about stoichiochemistry of the addition reaction, where anti-addition at trans compound, right? DL erythro form will form, right? Now I will clear that. Once again, you can see, if anti-addition at cis, then DL erythro form, right? So you can see anti-addition at cis. Cis means A same side, B same side, right? Now you can see if A same side, B same side, then, right, here NU come from above the plane, E come from below the plane, right? And then E come from above the plane and NU come from below the plane, right? Now you can see this is very simple. Now the point is here, because anti-addition, because क्या हो रहा है, anti-addition हो रहा है, because क्या हो रहा है, anti-addition हो रहा है, इसका मतलब क्या हो गया? It means your product is not eclipse type, your product is actually stagger type. आपका जो product है वो क्या है, stagger type है. आप देखिए NU above the plane, E below the plane, E above the plane, NU below the plane, right? So this is a very important point. You can see this is very important. Now same point, now we need to convert